Let's work on our putting our infrared detector emitter pair in our nozzle, or our barrel. And what I've done ahead of time is spray paint the interior black, and this helps reduce the reflection of infrared light. And we also need to put this in so that it doesn't twist, because we're going to drill a hole in it. One of the things that helps with this gluing is to scuff it up a hair, like so. I'm just going to run a bead of super glue around it. Nothing too special here, and then insert it in there, and then second part of this is to figure out where exactly the infrared sensors are going to go. And so we're going to reinstall the barrel here. And again, this works a little bit better if we scuff things up a hair. The shell, and what we have are some 3D printed parts that are going to hold the infrared emitter and the photodetector in place so that we can get a good alignment. So let's start on the back side here. So the shell is actually not symmetrical. Quite a bit thicker on the back side. So I'm just going to spread some glue around, and we're going to drop it in. There's like a concave section that should match the barrel. And we're just trying to get it into this this kind of toothy opening from the shell. And I'm going to hold my finger on it just to kind of hold it in place so we work the front end here. Some more glue here. And then what we're going to end up doing is just coming in and drilling this section out so that we have a nice alignment of our holes. So with that in place, assuming I haven't glued it to my fingers. It's not sticking quite as well as I'd hoped. I guess the other way to do this would just be to mark the I'm gonna glue my fingers on. Okay, shell comes off. That comes up. And as you can see, we didn't quite get them perfect. And the glue's not quite set yet, so I'm gonna slide it just a hair. So we're gonna want the infrared going directly across and hitting the photodetector. Alright, so let's set that shell. Okay, so what we're going to need, I've designed a couple little circuit boards to help us out, and we've got a black package is the photo transistor, and the clear package is the photo emitter. And we're going to end up coming, so the signals coming from the board are power for the infrared emitter, which is already has a current limiting resistor on it, the 100 ohm resistor that we saw earlier, and then the going to have the line going back from the transistor, which is already pulled up to 10K, and then we're going to have a ground wire. So we'll just end up with 3 wires. And so this is the photo NPN, and I've got some lines on the silk screen showing which leg is long and which leg is short. Like so, and similarly with the IR LED, long leg is positive and the short leg is negative, and that'll go in, and that's the clear package again. And let's solder that in place. So, and we will clip it flush with our flush cuts. And infrared emitter detector. So if you see any of my instructables on the chronograph, kind of explain a bit about how this system works. And we're just shining the light across the barrel, and then as the dart comes through, it will break the beam, and we'll kind of start the clock or get a clock reading. And then when the dart passes, we know it's about 72 millimeters in length, and we'll measure that time in microseconds. And that information gives us what we need to figure out the speed of the dart, as well as the fact that a shot has actually occurred. And that makes life interesting for us. Okay, so we need 3 wires, like I mentioned, signal, ground, and power. So I'm going to grab 3 pre-crimped wires, and I know that they need to be, oops, we're missing. I know they need to be about 6 inches long, and these wires are 12 inches long, so I'm going to fold it in half. And clip them. And we will save those other 3 for something else. Okay, power signal, ground. We just need to strip about 1/4 inch off here. And give them a little twist to help all those strands stick together. Okay, we want our photo NPN, so it's got 2 pads on one side and 3 pads on the other. It's negative, positive, and C, which is the cathode, which is going to be our signal, cathode of the, the collector of the NPN transistor. See, sometimes I don't even know what I'm talking about. So that's going to be the colored wire, which I've just kind of picked as yellow. And the others are going to be, the ground is black and the red is power, which are kind of standard. Okay, let's do our red. And again, we don't want any strands floating around because that can cause shorts. Get my tweezers on just the red. That will help kind of hold the place as it solders. And boy, yeah, I tell you what, so I'm working behind a camera, trying to give you guys the front row seat. Makes it a little bit tougher on me, but seeing how I'm trying to pretend to be the expert here, I should be able to do this. Okay. And then our ground. And you know what? I got a little bit of solder on there, so it is time again to show you how the solder wick works. I've covered up the pads and holes for the ground, and that's not what we wanted. So with my solder wick clean section held over the ground, I'm going to come in and try to do this without causing too much of a burn, but I'm usually watching the wick itself, and I'm not sure this will show up on camera, but you'll see the shiny solder kind of wick into the solder wick so that you know it's flowing. Sometimes it takes a try or two. And of course I could edit that all out, but I want you guys to see that stuff happens. You gotta just have a positive attitude, persist, and have patience. Those are my 3 P's. Positive attitude, have persistence, and have patience. And you can do it. Oh, there it goes. Okay, so clip these down. Okay, so now we need to cut a section of wire that will fit across from one circuit board to the other. And I'm using the other pieces of wire from the section cut for this guy. And we're just kind of ballparking it here. We don't want it to just fit over. We can take some slack. So there's about 2 inches. And let's strip about quarter inch off each end. Okay, bring our tweezers back in. So we're going to go from, we've got a negative and a positive, so let's do negative first. I'm sorry, positive first. Let's be positive so we can get this to work. And if you got sharp eyes, you can see there's already solder on these pads because I've already tried this once and the camera messed up on me. So we are on take 2. is where if you have a friend to help you hold, it gets a lot easier. I am by myself tonight. So okay, so we're coming across, we're going to come in the same side that we've got the infrared LED on, so we're looking for the positive. And the negative. Well, cut that flush. I'm going to come in and touch that up a little bit because that's not a good joint there. If you can still see the pads, the gold from the pad, then you know you didn't quite get enough solder in there. And for some reason my iron started acting a little squirrely. So by now the glue's dried on our thing, and got 7/64 inch drill bit. We just need anything big enough to get through here, the size of a 3mm LED. Like that, and just looking through, I can hard to see on camera, but I can tell we got a straight shot through, so I think we're looking good. And so that's our NPN is going to go on there. PNP is going to go on there. Yeah, this is looking really good. We're going to come in, we'll put a little hot glue on here to tack these in place. So holding our header up here. So pin 1 will be on the right as we're looking at it. So negative, positive, and signal. And so these have a little tang on the top, and those are what slide in and lock under this little plastic finger here, so they lock in place pretty nice. And if you need to get them out, I usually use an X-Acto knife and just kind of pry up a little bit on the plastic until this will slide out, and then you can use your fingernail to push the plastic back in. So you can pin and unpin these a couple of times. Not too much trouble. And so our 3-pin header is right here. So that's in place. Now we need some batteries. System here. Trusty pair cells. Start a beep, which is good. And we've got our debug screen back up. And what we're looking at is this upper right corner says IR, and there's a value of about 20 on there right now. So this is a 10-bit analog value, so it reads from 0 to 1023. So the low value means that it's getting some good infrared light across it. And we're just going to introduce a dart, and what you'll see is the value goes way up to 950 roughly. So if it was completely occluded, it'd be over 1,000, but so that's a really good range. So we're going from about 20 to over 900. So we've got most of the scale covered. And you heard that beep. That beep is the firmware that is figuring out a dart just passed, and the FPS is going to be really low because I'm leaving it in there for seconds upon end. I was looking for really milliseconds. So that indicates to me that the system's working good. So one of the troubleshooting things is if you're not hearing a beep or you got a high value, come in here and with a camera, so to the visible eye you can't see this, but a camera that doesn't have a good IR sensor, like a cheap cell phone camera like I have, or this camera right here which is older, you can see the IR light emitting. And when I have that IR light out, you can see that we're getting those higher values because the infrared, the photo cell is not getting any reading. There's not seeing IR. So that's your first clue. If you've got a high reading, then you're not getting any IR. So check to make sure you've got your light going, and then start looking at whether you've got a clear path across. Make sure there's no little filings left over from the drilling. And so you should be seeing a low reading when you're getting a good IR light.